The title of this is Inspector's Toolbox, and I think we stole that from the NHI Drill Shaft Inspectors workshop material. So in one way, it does show some of the physical tools that you might use out in the field, but a lot of it's basically related to like organizational type things. Just there's a lot going on out there, so these are things that help you to be organized. So this is a checklist that they include, and you can see some of the major categories. You know, the approved job information like the specs and the installation plan, etc. Any references like the drill shaft inspector's manual, testing equipment that you might be required to use out there for testing slurry, concrete, or other materials, the forms like we just went over, and then just other stuff that you have to have out there, your personal safety equipment, everything you need for making measurements and recording all the information. So let's talk a little bit about some of those. So this would include you know, all the information relevant to that project. So the documents, a lot that we've identified previously, right? So the specifications, the plan drawings that are relevant to the foundations, the installation plan. And so that I think we probably already beat that horse quite a bit, but in the geotechnical report, something, whether it's the plans or that report with the boring logs. Some other things that are good to have, you know, the notes from this class, and I think we're going to provide PDF copies of all these slides, and that could be a reference for you. Any other applicable MnDOT standard specs, like for the concrete. Any testing that is going to be done out there, for example, the concrete testing, what are the applicable ASTM or other standards. That little green CDSE drill shaft inspector's manual is a really handy thing to have. So I've seen a copy around here. You should probably take a look at that. And then if those of you that have taken that NHI course, you might share some of that information with your colleagues. And so another category here would be some of the testing equipment. And I am not clear whether like the inspectors would be responsible for any of the slurry testing on this job, but from what I heard, maybe that's the contractor's responsibility. But even in that case, just as kind of background, you probably ought to be familiar with what they're doing. The drilling fluid, the polymer slurry, you saw earlier there's a set of specifications that go with that, and some of the properties that are important to its performance and which are governed by the specification are things like the viscosity of the fluid, and the test that you would see conducted in the field is called the Marsh funnel viscosity test. Pretty straightforward. It's not really the viscosity, it's an indicator of the viscosity. There's a funnel, and it has marks on the inside, one at the top, one at the bottom. The volume of slurry between those two marks is 1 quart. And so the person running the test uses a stopwatch to time it takes for the slurry in the funnel to drop from the top mark to the lower one. That's 1 quart. And that time in seconds is what we call the Marsh funnel viscosity. So, you know, the spec for the polymer slurry, it might be 40 to 60 seconds or something like that. And it might be also specific to that particular product. That's something the manufacturer will specify. And then the density or the unit weight, they just measure that on a mud balance like that. You fill a certain volume of that container right there, and then you balance it and read off in pounds per cubic foot what the density is, and that has to be within a specified range. Then that sand content test, you're basically by weight determining what percentage of sand, and anything coarser than that. There's a little sieve screen inside there that basically retains the, I think it's the number 40 or coarser, so you can determine the percentage sand. And you want for example, before you place concrete at the bottom of a shaft, if you're using polymer slurry, you want the sand content to be less than 1%. And the method that's being specified here, that is to completely replace the drilling fluid after you're done drilling, and then before you place the concrete, probably will make that a moot point, okay? But still, they'll have to measure that. And then also the pH. If that polymer slurry becomes too acidic or too basic, it's not going to perform the way that it's supposed to. So we use pH strips to do that. And then, basically, probably a lot of you are do this on a regular basis, very familiar with all the tools that you need to do slump tests and air content, so forth on the concrete. Then just another category here, the forms. Any questions or comments about the forms? So it sounds like you have a standard set of forms, and so Rich said there could be some improvements there, but I guess you can always do that if you want to. I think those FHWA forms are meant to be kind of generic, and you're certainly encouraged to revise those for a specific job or as you see fit. And then all the stuff that you need to make measurements and for safety out on the job. So of course all your personal safety equipment, I'm sure I don't have to tell all of you guys about that. And then some of the other tools that we mentioned earlier, say a 12-foot tape for measuring tool dimensions and smaller things. You want a weighted tape, a long one, long enough to get to the bottom of the hole. So how many people in this room have sounded the bottom of a drilled shaft with a weighted tape? Okay, so quite a few. And those of you that haven't, it's a good thing to become accustomed to, and you'll probably get the opportunity out on this job. And as you might imagine, dropping that weight off the bottom of a rock socket is going to feel quite a bit different than the base of a drilled shaft in clay, and that's going to feel different than the base of a drilled shaft in sand. It's also really good to calibrate your feel for that by comparing how the base feels with what you get from that SID test. That SID test is telling you about how much sediment is down at the bottom, and you'll feel a difference between that thing, bouncing off the bottom when it's got a bunch of sediment in it versus, even a half an inch of sediment versus an inch and a half of sediment. So it's one of those things only experience can really give you a good feel for that. So a lot of things, right, to think about here. So don't forget the other essential stuff. Then just a few of the real basic things you'll need out there that we just sort of outlined. So yeah, your phone with a camera on it, that's really one of your essential tools these days. Stopwatch, and monitoring, like David said, when did the tool go in the hole? When did it come out? At what depth were you at when that happened? And we'll talk a little bit more in a little bit about the other things you want to look at when they're doing that. Yeah, a level for measuring, monitoring the verticality of both the casing, the Kelly bar, plumb bob, rulers, pens and pencils, all the stuff that you need. And again, I'm guessing those of you that are inspectors are well versed in all this kind of stuff. So there's an example using a level. I know that looks like about a 4-foot level or something like that, but you want to monitor and document the verticality of the casing. They'll be doing the same thing. Of course, the contractors folks will be doing that, but you also want to do that and be discussing that with them, and is all that being done in accordance with the specifications. A lot of these newer rigs, in particular, I don't know if the contractor would have some of this stuff, but you could encounter it. A lot of them now are equipped with electronic monitoring, where they're able to monitor everything about the operation of the rig, in some cases from which you can infer something about the drilling that's going on. So things like they're monitoring basically all the pressure in all the lines that are providing torque and down force on the tools. And sometimes that can be informative about what's happening down at the tool level. So, and a lot of this stuff now, it makes a record of all those measurements for the entire duration of the drilling, and that's all basically data that could be available later on a computer. So I see a lot of this stuff on some auger cast pile rigs, sometimes more than with drilled shafts, but we're starting to see it on the drilled shaft rigs. And some of your basic tools, okay, so there's an example. You know, a weighted tape is basically just that, and I've seen every imaginable sort of way of making weighted tape. There's really no standard weighted tape. Like people will use a piece of number 18 rebar and just wrap it around the end of the tape with duct tape, like you see right there. That works until it doesn't. So there are some inspectors, got their hands in their pockets, you know, sounding the bottom of a drilled shaft excavation. It's a great tool, really, especially if you've done it a lot and you've sort of gauged yourself as to what different materials feel like. Someone who's done a lot of that can, you know, do that and tell you exactly what's going on down at the bottom of the excavation. And then this shaft inspection device, or SID, and not sure how much you've seen of this, but basically, as David described, it's a cylinder, and it has a camera that's sealed on the inside up above here, and a bunch of lights to illuminate the bottom of the hole. So you're putting this cylinder all the way down, resting it on the bottom of the shaft. And there's not a real good example of it in this photo right here, but what it has down at the bottom on the inside, it has a triangular piece of plate, and then it has pins coming off it horizontally. That would be this contraption you can see here. And those pins are in half-inch increments off the base. And so by looking at how many of those pins are not visible, you can say, oh, okay, the sediment is at least, you know, like if the first pin is covered and the rest of them are visible, you say, well, there's more than a half an inch of sediment. And in fact, we would say if the second pin was visible, we'd say 1 inch. If it was buried up to where you can only see the third pin, you'd say, oh, well, it could be 1.5 inches of sediment. So pretty useful tool. And what you would see, so the operator, and I think it might be in the subsequent slide right here. Yeah. That thing is lowered down the hole. It's got all the cables that comes up the hole, and then you're looking at basically a monitor screen, usually inside this little trailer right here with all these guys looking over your shoulder. And what you would see, so there's kind of a blown up view of what I was talking about. You have this triangular plate there with the pins, and the pins are in half-inch increments. So you're up in the trailer looking at this on the screen. This is what you see. There's the bottom of the hole, and it's kind of hard to tell right in this one here, actually. The pins would be in this direction, right? Perpendicular to the plate like you see right there. So depending on how many of those pins are visible, you can make an assessment of how thick the sediment is. And the one that I'm used to seeing actually has 3 of these. You know, 3 of these plates mounted with the pins around the perimeter there. And so you can get like 3 measurements from one SID shot, okay? And all of that is basically also recorded with the voiceover. The person making the inspection there at the monitor says, okay, this is hole number such and such, it's this time on this date, and I see, and you say how many pins are visible for each of the measurements, and recording that. So the criteria, a typical criteria, and one that we find is adequate, if you pass it, you're getting good base resistance, is that if for at least 50% of the measurements that are made, all the measurements made in one at the bottom of the shaft, if at least 50% of them are less than half an inch, and no readings are more than 1.5 inches, that's a passing criteria, and that seems to work. That seems to provide good, and assuming the concrete is placed properly, you'll get good base resistance. And then, so like I was saying, it's good to calibrate yourself, your weighted tape feel, with what you find you're getting in your mini SID measurements. And there's the data sheet, and David already showed this. And usually you make a measurement right in the center of the shaft, and then at the 4 quadrants, at the north, around the perimeter at the north, east, south, and west sides. And on that form, for each one of those, I'm used to seeing not this, like 100%, just how many of the 3 measurements, for example, were less than 1/2 inch, how many were, less than 1.5 inch. So different ways to record that. Okay, and then, so this is just summarizing. We looked at this slide before, the different phases of the project from setup through installation, and it just highlights what are some of the tools you need for each of that phase. So, when in the setup, you want all the documents, especially the installation plan. You want a tape measure to measure the tool diameters, make sure they're consistent with the plan, etc. Take pictures of all the tools. When they're excavating the shaft, if slurry testing is part of that, you want all that equipment. You're constantly measuring how deep they are in the excavation. You can use a weighted tape for that too. All the forms that need to be filled out, like the excavation log, etc. And then when these are tools that you would need to document the cage conforms to the plans, and then monitoring them when they're lifting the cage, for example, observing and taking pictures of that. Same thing with concrete operation, and then afterwards. Each phase, there are tools that are going to be the most important.